Alrighty, construction dorks, we have an AR experiment. So we have these complicated clouds, and I'll insert a video of me explaining it in more detail, but I'm just going to jump into it so I can get the guys in the shop working. So to better describe what the rest of this video is basically we have these clouds. This is an auditorium, and ignore the line work. This desk is just meant to indicate where the heck the stage is, and these walls are just rough sketches. But actually, we can just delete them. I really don't need them. Yes, I realize I could hide elements, but whatever. I'm not going to save this anyway. Basically, we have these clouds, and you can see first they're not all at the same elevation. So your aircraft cable is at different heights or lengths. So they hang at these canted angles. Second, they're radiused. So we're prefabbing these, and getting all the geometry right is challenging. The clouds are 2 feet off these walls, matching the same angle as the walls. They have basically a 5 foot, 4 foot, 4 foot, 4 foot, 4 foot, 6 foot sweeps all the way across, maintaining radiuses, and then they're at these angles. So it's a lot of complex geometry, 20 feet in the air. So in an effort to try and help us visualize and test some layout and how we were going to fabricate these in the shop, we thought we'd give AR a try, which is what the rest of this video shows. And I'll let you see what the results are. I'm not going to spoil it for you, but that's basically what we were trying to solve. We ended up coming up with a solution, which is later in the video, and we go into fabricating these as I'm recording this reinsert, which is July 11th. We go into fabricating these next week, so I'll be sure to document that and the whole installation process and what we ended up doing. So check out the rest of the video for our 30-minute AR adventure.
Don't touch the ball, it's over, call it close, but we all know what this is gonna be. You came and failed the test, you met the best, expected chess, but got monopoly. I came and bought you out, I knocked you out, I cropped you out with no apologies. I am the hope, the heart, the faith, the spark, the one who will fulfill the prophecy. I just been counting, never lounging, climbing up mountains, bouncing back. Step in the ring, about you step back. They'll learn hot when I get on the track. I like it louder than most, watching all these sheep just buy down to the goat. If I can't decide, I'ma probably get both. We can celebrate, but right now I'm a toast, resurrected ghost.
So as you can see in the video, basically the app is just something we built in Unity, was quick and dirty, and we used a target. We placed the target directly at one of the corners, which you can see showing up right there. As you can notice in the video, and what we discussed pretty much the whole time was, one, as soon as you looked away from that marker, the object would disappear. And the other main issue was the scale of the object. So that cloud, which I ended up just modeling the perimeter just to save on memory and all that kind of stuff, we set up, which you'll see we just placed under a template. So they're very large radiuses, about 90 feet. We placed it directly at the corner, set up a jig, and tried to align that. You can see us trying to rotate the model using the target to get it to line up with what we had there, just to try and visualize what we're doing. But the issue is, all the way at the other end of the table is 12 feet, and the model just really wasn't getting displayed properly, for lack of a better word. And you can see it was really finicky. As soon as you looked away, it would disappear. The scale is very hard to manage. In 2020 hindsight, we probably should have set the model somewhere in the middle of the table. But what we were basically trying to accomplish was, as you saw earlier in the video from the Revit model, there's these large complex clouds, and we divided a cloud into panels to make it easier to prefab, and also obviously ship and manage in the field, standing in a scissor lift or an aerial lift when they go to install them. So we were having issues, there were so many complex geometries, and also laying out where mains go and all this stuff. So we built one template as a test, just to kind of learn basically what we're doing, and we're trying to test different ways to get layout right and get the angles right and all the shapes and geometries. As you can see, we're trying to get the angle right there, which was basically an offset of an angled wall inside of this auditorium. Again, the AR, it just wasn't super useful, to be completely honest. It was simple, dirty targets, but all in all, it was a nice experiment and something to keep in mind, and try again in the future. If you guys have any questions about what we did, want some more detail beyond just what I'm sharing here, feel free to reach out to me. Always happy to share, what I did, the processes, what we learned, all that kind of good stuff. So thanks for watching. To more fully describe what we ended up doing is we basically drew that table, which was 8 by 12 inside of AutoCAD, and correctly laid everything out off of that jig, and we used the table as basically a jig to help with layout. Isn't the most optimal solution, but it was one that worked for the time being, and just given the time crunch, we didn't really have the ability to try anything else out for this particular instance. But we learned some things, and we'll keep those in our pocket as we continue to move forward with other projects.